Hi, and welcome to this Python 3 Deep Dive Part 3 course. My name is Fred Baptiste, and I will be your instructor for this course. So what is this course about? Well, broadly speaking, this course is about the Python language. It's about the standard library. So I'm going to be using the canonical version of Python, which is the C implementation. And in particular, I'll be looking at using Python 3.6 and above. So this course is about becoming an expert Python developer. It's about writing better Python, more idiomatic Python, and being able to fully leverage the built-ins and the standard libraries by understanding what's already available before we turn our attention to third-party libraries. So it's about a deeper understanding of the language, of the Python language itself. And of course, the standard library, since it's part of the implementation, it's part of the distribution of Python. Now, this is not an introductory course. There are prerequisites to this course that you will need in order to be able to follow along. And I have that documented in the course description, as well as in the next video, where I'll talk about those prerequisites in some detail. Now, there's a lot of course materials that are included. Obviously, you have the videos, and usually the videos are split into two. We have lecture videos and coding videos. So the lecture videos, basically, I go over more the theoretical aspects, or maybe I'll discuss more general topics and general concepts. And in the code, we actually go and actually write code and write implementations and see how things work and how things break and how we fix those things. So for the coding videos, what I really suggest that you do is that you don't just sit back and watch the coding video, but you actually code along with me. So pause the video once in a while, type in the code, play around with it, make changes to it, experiment, break things, see what happens. That's the best way of actually learning and figuring out how these things work. Most of the code is available as Jupyter notebooks, and they're fully annotated. So not only does it cover the actual code that I'm doing in the code videos, but it also contains annotations as well. And that's why I use Jupyter notebooks, because that's really handy for that. We also have projects, exercises, and solutions that are available throughout this course. And all the Jupyter notebooks and all the projects and the solutions are also available in a GitHub repository, and it's available right there. Now, I really suggest that you use the GitHub repository as opposed to downloading the files from here, because the GitHub repository will always have the latest and greatest right away. That's where I make the changes first. If there's a bug in one of the notebooks or I make some addition or some tweaks, it will show up in the GitHub repo first. So what are we going to cover in this course? Well, this course is actually going to be focused on one thing, technically, associative arrays. So we'll take a look at what are associative arrays. That's an abstract data type. And in particular, there's one concrete implementation that we're going to study in this course, and that's the hash map, or the hash table, or the dictionary. So we'll take a look at how do hash maps work in general, and I will give you some theoretical background on that. But it is not a theoretical course, so I'm not going to give you all the details. I'll do a little bit of hand waving to explain away some of the complexities of implementing hash maps. But by the end of that, you should have a good solid understanding of how they work, and in particular the parts of it that are important for the things that we're going to study later on in this course. In particular, we will take a look at hash functions and see what they are, how they work, and why they're important for us to understand, because we'll need to create our own hash functions later on. Then I'll look at Python's specific implementation of this hash map, because there are some extra tweaks that Python 3.5 and above have introduced to make dictionaries even more efficient. Now let me ask you this question. What do modules and namespaces, classes, all these are Python objects, right? They're Python things. Their modules are in Python. Namespaces like globals and locals, classes, instances, sets, even function arguments, for example, or multisets. And if we even look outside of Python, we can look at things like JSON, or we can look at YAML, or even relational databases. There is one common theme to all these things, and many others that I don't mention here. What do you think that is? Dictionaries. Dictionaries is kind of a central piece of Python. It is ubiquitous. We see dictionaries everywhere in Python, and they're really very efficient in Python. And then we need to therefore study dictionaries and understand them well in order to be able to leverage them properly. So we'll study dictionaries in a lot of detail. You probably already know how to create and manipulate dictionaries, but we'll dig further in and take a look at some of the more detailed aspects of creating and manipulating and updating and merging and copying dictionaries. We'll take a look at the views, the keys view and the values view and the items views that are available on dictionaries. We'll see how they work and what kind of properties they have. We'll see that they're both iterables and in some cases sets as well. Then we'll look at how we can use custom classes and hashing using custom hash functions to be able to use instances of our custom classes as keys in a dictionary. We'll see how it works by default and then how we need to tweak that in order to make it work probably more the way we want it to work. Then we'll look at sets, and as we'll see, sets are actually hash maps as well. You can think of them as specialized kinds of dictionaries. So we'll talk about set operations. We'll take a look at some very simplistic set theory, things like unions and intersections, complements, the empty set, things like that. Then we'll take a look also at copying, merging, and updating sets, and we'll see that there's a lot of commonality with dictionaries, because essentially they're the same thing. Then we'll look at frozen sets. Frozen sets basically is an immutable set. So just like a tuple, you can think of a tuple as an immutable list. The frozen set is an immutable set. And then we'll look at dictionary views again, but this time we'll look at dictionary views under a different lens now, under the lens of sets. And so in particular, we'll look at the keys and the items views of dictionaries. Next, we'll spend some time focusing on serializing and deserializing dictionaries. That's something that's really important and very practical. So we'll use pickling, and I'll show you how pickling works. And it's a native format for serializing and deserializing in Python. I'm not going to spend a whole lot of time on it. It's pretty straightforward for the most part, and it's easy to use. It has some, complications, let's put it this way, in that it's not actually safe. And I'll show you how you can hack things to have people execute code unwittingly when they're deserializing your objects. So I'll show you that, and I'll show you why you have to be really careful when you use pickle and unpickle, especially with third-party data. Now, that's not the case with JSON. JSON is safe. So I'm going to focus on JSON serialization and deserialization. It's something that's used frequently. It's a way that we can basically save data and pass it off to somebody else. Or we can generate data, pass it off to somebody else, and they can load that up back into some objects. REST APIs use that all the time. So I will focus on JSON serialization and deserialization. And we'll see what we have built into Python, and then we'll see how we can customize that further by using the JSON encoder and decoder classes. But we'll also see that we actually really want to put some structure on our JSON, and it's called JSON schemas. And I'll show you one of the standards that's available, and then we'll even create our own standard for certain things. And we'll see how we can use that effectively when we're deserializing JSON data into Python objects. And then I will introduce some third-party libraries, because there's a lot of stuff that we really want to do when we're doing JSON serialization and deserialization, especially the deserialization, that's just not available in the Python built-ins or the standard library. Now, I'll show you how we can, mimic some of that stuff, how we can do some of that. But as you'll see, it's quite a lot of work. And so here I will introduce a few third-party libraries that I'll cover very briefly. And then if you're interested, you can go and take a look at those and their documentation and get more familiar with them. So the ones I'm going to introduce are JSONSchema, Marshmallow, PyYaml for handling YAML files, and Serpy or Serpy. I call it Serpy, but it's pronounced probably Serpy for serialize Python. Then we'll take a look at the specialized hash maps that are available in the standard library. For example, the defaultDict and the OrderedDict. And the OrderedDict, I'm going to do some comparisons and contrasting with now the built-in dictionary type in Python in 3.6 and above. But prior to that, we didn't have guaranteed order of keys in dictionaries, and so the OrderedDict was really useful. But OrderedDict has a few more tricks up its sleeve, and we'll see that we don't have those available in plain dictionaries, but I'll show you how we can essentially recover that functionality. Then we'll look at something that's really interesting and really useful, the counter object. Essentially, this is Python's implementation of a multiset, if you're familiar with multisets. Then we'll take a look at the ChainMap. ChainMap is very similar to the itertools chain function, but the chain function is chaining iterables. The chain map is chaining mapping types, dictionaries, for example. Then we'll look at custom dictionary types. Now, I don't mean custom dictionaries in the sense that we have custom keys and values in the dictionary. I'm talking about being able to modify or add on to the functionality of the basic dictionary. For example, we may want to create a dictionary where only certain keys are allowed, or only certain values or types of values are allowed. So we can do that by creating essentially a custom dictionary type. So I'll show you how we do that, and we'll start by inheriting from the basic dict, right, which is the built-in dictionary, Python dictionary. So I'll show you how we can do that by inheriting from that class, but then I'm going to show you what are the drawbacks of doing that. And I'll point out that this is not a course on object-oriented programming, but I will use inheritance, and I will explain what I'm doing as I go along. So as long as you know how to write classes and do an init, things like that, you'll be okay. Now, I will then go on to show you why inheriting from UserDict is probably preferable. It probably will work the way we expect things to work, because a few things when we inherit from dict won't work the way we expect them to work. And then finally, exercises. There are exercises after each section. So you really should be attempting those yourself first. Some of them will be easy. Some of them will be a little bit more challenging. But that's good practice. That's the best way to learn, is to actually code. Which is why I also encourage you, when we're doing the coding videos, to pause that video and just play around with the code yourself. Try things out, see what works, see what doesn't, and experiment a little bit. You'll retain things better that way. So solution videos and notebooks are provided for every exercise, but those are going to reflect my approach to how I solved that problem. And it's going to reflect my approach at the time when I created the solution. A month later, I might be looking at the solution and thinking, well, I could have done this differently. And most likely you'll come up with a different way of doing it as well. That's perfectly fine. So they're just my approach. If you have, another approach that works well, please go ahead and post it on the Q&A. Everybody would be interested and would benefit from seeing different ways of solving the same problem. All right, so that's what this course is about. In the next video, I'm going to talk about the prerequisites. So again, this is not a beginner course. If you're a Python beginner and you don't know those prerequisites, you're going to have a hard time with this course, because I'm just going to assume that you already know those things. I'm not going to spend time explaining things like iterables and iterators and generators and things like that. I'm just going to use them and assume that you know what they are and how they work. All right, so I hope that this is a course you will find interesting, and I hope you'll join me in taking a deep dive into Python dictionaries. Thanks for watching, and I'll see you in the next video.